Okay, so page number 4. Ayan, so page number 4. For page number 1, you can see there the introduction, the content standard, the performance standard, most essential learning competencies, the learning skills, and the core values. So I hope that you already read them. We will not discuss those things for today because we only have 30 minutes. In Module 1, for the first part, we have the Earth's interior. This is a basic topic because it only focuses on the layers of the Earth. And alam naman ninyo lahat siguro yung mga layers ng Earth, di ba? Okay, so we have the crust, the mantle, and the core. The core is subdivided into 2 layers, the inner and the outer core. Now, on page number 3, we have the different discontinuities. These are the boundaries between the layers of the Earth's lithosphere rather. So we have the Mohorovičić, the Repiti, Gutenberg, and the Lehmann's discontinuity. On page 4, that will be the start of our our discussion for today. We will focus on the mapping the interior of the Earth. So for this topic, we will focus on the main idea, which is seismic waves help map and characterize the layers of the Earth. So later on, we will discuss the definition of seismic waves and how are they related with the discovery or the identification of the layers of the Earth. To help us arrive with our main concept or main idea, we will be guided by the essential question. And our essential question will be, how did scientists learn about the structure of the inner Earth or the interior of the Earth? So in short, paano na-identify ng mga scientists yung mga layers ng Earth, yung layers ng interior of the Earth? How did they come up with the idea that, okay, we have the crust, we have the mantle, and we have the inner core and outer core, without even going inside the Earth, right? So hindi sila nakapasok, wala pang nakapasok sa loob ng Earth. No one ever reached the mantle, no one ever reached the inner core and outer core. Because of course, we will consider the temperature and the pressure there. People cannot survive there, even the scientists. So, again, our essential question will be, how did scientists identify the different layers of the Earth? Okay. So, before our main discussion, I would like to present to you this picture. Siguro, yung iba sa inyo familiar to. O, ano to? Anybody from the class? Are you familiar with this picture? Where is this?
Baguio.
Ayan, Baguio. Very good. Thank you for that. Okay, Baguio. Di ba? Ang ganda ng Baguio. Pagpunta mo pa lang, pagbungad mo pa lang, makikita mo yung mga madaming bahay, tall buildings, and scattered everywhere. So talagang malaki yung population doon. Of course, we are aware that it's the summer capital of the Philippines. So every summer, madaming mga tao doon. But of course, due to the pandemic, medyo nabawasan. Okay, so eto, how about this one? Anyone from the class? Are you familiar with this one?
Rainbow houses.
Saan mo ito makikita? Saan natin ito makikita, class? Ayan, rainbow houses, sabi nung isa. Okay, so this is actually taken, a photo taken at Baguio also. Ayan. Okay, so, napakaganda ng Baguio. But you know what? During the 1990s, July 16, 1990, Baguio was hit by an earthquake. Ayan. So this is very familiar. So hindi pa kayo naipanganak nito. Maybe 2000 plus kayo naipanganak. Ako 1993. So even me, hindi ko na-witness yung earthquake na ito. So this is the picture taken during the 1990 earthquake at Baguio. This is Baguio Park Hotel. So you can see the damages brought by this earthquake. Next one, we have Baguio City Public Market. Okay? So talagang nasira yung building. Okay? Another one, also taken at Baguio during the 1990 earthquake. Okay. So you see, earthquake. How is this related with our topic? Yung earthquake na alam natin, madaming mga damages, madaming mga casualties brought by earthquakes. This is, of course, a natural calamity. But you know what? The earthquakes or the seismic waves coming from earthquakes are used to identify the different layers of the earth, as we have stated in our main idea during the introduction of our lesson. So, what are earthquakes? Earthquakes provide clues to determine the properties of Earth's layers. Earthquakes are, of course, the vibration of the Earth's ground. Ayan, so basically, yung ating definition dyan, pagka gumalaw yung ground, yung Earth's ground due to volcanic eruptions, what else? The disturbance of the plates, what else? At madami pang iba. So, yung una nating maramdaman ay of course yung paggalaw ng buildings, ng ground. Okay. So, I repeat, earthquakes provide clues to determine the properties of Earth's layers. What are seismic waves? These are waves of energy that travel through the Earth's layers and are a result of earthquakes, volcanic eruptions, and magma movement. So these are waves coming from the Earth's layers that are produced by earthquakes, volcanic eruptions, and magma movement. So whenever there are movements of the Earth's layers, meron tayong naproproduce na seismic waves. And these waves carry the energy that is capable of moving buildings, of moving the ground. So to measure or to quantify seismic waves, we have seismometer or seismograph. These are instruments used to record the movement of the ground, record seismic waves. So, eto siya. Nakikita ninyo sa screen. Nakikita mo ba sa screen, Mr. Duldulaw?
Yes, sir.
Okay, very good. So, how does it work? A seismograph works through this concept. So, yung ating... Nakikita ba yung cursor ko?
Yes, sir.
Okay. So, ito yung ating machine. This is a basic drawing, a basic diagram. Hindi lang ganito kasimple yung ating seismograph. So, meron tayong nakabitin na weight. Andito siya. And then may, let's say, a ball pen, a pen. Pagka gumalaw yung ground, nag-move etong ground na to, gagalaw yung part na to. So, pag gagalaw yung part na yan, of course, this one, the base, is connected with a frame. Meron tayong fixed mass. Okay? So, pag gagalaw gagalaw yung etong part na to. Pag gagalaw yan, of course, a pen is connected to this one or a recording machine, a recording instrument, magkukurit sa Ilocano. Magkukurit. Parang kapag sinulat natin sa papel, may mark doon. Of course, these markings will be interpreted by our seismologist or the scientists who are studying seismic waves. Okay, so we have here a diagram of how seismic waves travel. Halimbawa, meron tayo dito. Ito yung pinagmulan ng ating seismic waves. So the seismic waves will travel in all directions. So this one, the original origin, This is what we call the focus. This is where the earthquake occurs within the Earth's crust. On top of it, dito sa ground, sa surface, it is what we call the epicenter. Of course, you learned this one when you were in grade 8. Epicenter. So the seismic waves radiate out in all directions. So maring dyan, ayan, yan, in all directions, producing the different seismic waves, which we will discuss later. Okay, so what are the type? We have two types of seismic waves actually. The first type is the surface waves, and the second type is the body waves. For the surface waves, we have two types, Rayleigh wave and then the love wave. Okay, so bakit kaya Rayleigh, bakit kaya love? Okay, so Rayleigh, the effect of Rayleigh is this one. Pagka titignan natin dito sa diagram na to, yung effect ng Rayleigh sa ground natin, ayan, up and down motion. Parang waves doon sa ocean. Parang ganun yung movement niya. So, titignan natin sa diagram na to, rolling motion. It is rolling. Okay? It is different with love wave. Paano magiging different? Ito siya. Kapag ang Rayleigh wave ay wave-like or rolling wave yung kanyang movement, sa love wave naman, sideways. Okay? Sideways yung kanyang direction. Okay? So, pag i-observe natin yung ground, ang magiging effect niya ay eto. So, this is the road. Ayan, magiging parang snake yung paggalaw niya. Okay. Eto, up and down snake. Eto, sideways na snake. Can you get what I mean? Are you still there?
Yes, sir.
Okay, thank you.
Yes, sir.
If you have questions, I will give you time later on to ask these questions. Okay, let's proceed. We have the types of body waves. The first type is primary waves and the secondary waves. So primary waves are waves of energy that travel through Earth by causing particles in rocks to compress and stretch apart in the direction of the wave. Okay? So pag titingnan natin, eto siya. Waves are traveling this way. So the particles, the ground is shaking this way. Papunta dyan, and then babalik. Ayan. So mag-compress dito. Pag nakarating dito yung wave, mag-stretch, compress, stretch, compress. Alam niyo yung sling, yung spring na nilalaro ng bata, yung colorful. Ayan.
Yes.
Pagka binato mo pa harap,
Yes, sir.
mag-i-stretch siya. Tapos babalik, okay, magko-compress na naman. Na-imagine nyo?
Yes, sir.
Ayan, very good. So ganun
Yes, sir.
ganun yung effect ng primary waves natin. Okay, second type, secondary waves. These are waves of energy that travel through Earth by causing particles in rocks to move at right angles to the direction of the wave. Okay? So paano yung difference? Eto siya. Pag P wave, sabi ko kanina, meron tayong compression. Ito yung compression. Meron tayong pag-stretch, compression, then stretch. So if you move this spring back and forth, so magiging ganyan yung itsura. Okay? Ayan. So, titignan ko yung eraser. Okay. Ayan. And for the S waves, it's analogous with a string tied on a wall. If you move this one up and down, it will form this kind of wave. So this is S wave. Okay? This one is transverse. This one is translational. Okay? Later on in your physics, you will discuss that. Okay? So for the P waves, it can travel through solids, liquids, and gases. So always remember that. We will use that concept if we move on to our next next part of the lesson. So P waves can travel through solids, liquids, and gases. Solids can travel through concretes, any type of solid. Liquid, water, lava, anything. Gases, air, lahat ng klase ng gases, it can travel. P waves can travel through those materials. For S waves, unfortunately, it can pass through solids only. So solids lang pwede siyang mag-travel. Okay. So, now, for the next part of our lesson, we'll study the refraction of P waves. Dito, mapapansin natin, again, we repeat, S waves can pass through solids only. For the P waves, it can travel through solids, liquids, and gases. So, yung question natin, what will happen if P waves travel through different densities? Halimbawa, nag-travel siya from solid, pumunta siya sa liquid, pumunta siya sa gas. Anong mangyari? Diretso lang kaya siya? So, we will answer those questions as we proceed with the refraction of P waves. We will focus on P waves kasi sa S waves naman, solids lang siya magta-travel. Okay. Refraction of P waves. What do you mean by refraction? It's the bending of waves. So, in the first figure, we have the same. We have uniform density. Okay? The blue one. Pare-parehas lang yung type ng material. Example, concrete. Lahat to concrete. Etong box na to. Ayan, nakuan na. Okay. So, pag mag-travel si P waves dyan, diretso lang siya. So, there will be no refraction. Okay. Second scenario. We have the first one. This is ayan, hindi ko nakuha yung dense. Less dense. This one is denser. Okay, sorry, I'm only using mouse. Next time I will use my electronic pen. Okay. So, kapag ka ganito, nag-travel yung P waves from this point to that point, perpendicular to our boundary, from less dense to denser, straight lang siya. So, there will be no refraction. There will be no bending of waves. But, if the P waves will travel from this point to that point, so meron tayong angle. Meron siyang angle. So what will happen? It will bend. This bending of waves is what we call the refraction. So meron tayong bending. Okay, next. To better understand why waves bend, imagine natin to. Imagine natin yung sasakyan. Meron siyang gulong. It traveled from the clay part, papunta sa concrete with an angle. So, from clay to concrete. Ano yung clay? Yun yung sa Ilocano, pitak. Ano sa Tagalog yon, Andre? Anong Tagalog ng pitak? Ng clay?
Hindi ko po.
Sinong Ilocano, sinong kwan dito?
Sir.
Yes.
Putik.
Putik.
Putik, sir.
Ayan, putik. Putik, hindi potek. Putik. Okay, putik. From putik to concrete. So, ano sa tingin ninyo ang, if we compare the speed of the vehicle, saan siya mas mabilis? Anyone?
Concrete, sir.
Very good.
Concrete, sir.
Ayan, very good. Sa concrete. So, slow. We have fast. Okay, fast. So, imagine niyo na yung wave ay sasakyan. So, yung gulong niya dito, yan, saka yan. Pagtuntong niya dito, pagtuntong niya sa concrete, etong gulong na to, nakaapak na sa concrete. Yung the other side, still, nakaapak pa lang sa clay. So, mas mabilis ngayon si concrete kasi mas makapit siya. Kesa dito, bagal, kasi nasa clay. So, since this is faster, mas makapit siya sa concrete, ano mangyari? Yung motion niya ay magiging ganyan. Nagets nyo? Ulitin ko. Pag-apak ng gulong na to sa may concrete, mas mabilis siyang mag-move. So, ito, mas mabagal kasi nasa clay pa lang siya. So, pag mas mabilis yung movement dito, ayan, so, yung movement niya ay paganyan. Bakit? Nakamove na siya, ito, na-stuck pa lang sa clay. Na-stuck pa lang sa clay. Okay? So, nakamove na dito, na-stuck pa lang sa clay dito sa banda rito, so na-delay siya, causing the movement of the vehicle in that direction. Ayan. To better understand that, let's proceed to our next diagram. What if from concrete to clay? So again, as it reaches the clay, yung tar, yung gulong na to, nakaapak na sa clay, eto nasa concrete. So anong sabi natin? Mas mabilis yung pag-move sa concrete. So mas mabilis dito, yung pag-move niya, eto na-stuck siya. Kasi clay. So ang resulta, magiging ganyan. So the movement will be in that direction. Okay? Nagets nyo?
Yes, sir.
Yes, sir.
Ayan.
Yes, sir.
So in short, if the material, if the vehicle will move from slow, from clay, papuntang concrete, ganyan yung magiging itsura. Kapag ka concrete to clay, babagal yung speed niya, so magiging ganyan yung pag-bend niya. Okay. What if meron tayong different surfaces? Different uniform density muna, uniform surface. Pagsasakyan at uniform surface, halimbawa clay lahat. Nag-travel siya punta diyan. So straight lang siya. Kahit maggaling man siya diyan, straight lang siya papunta diyan. Although hindi straight yung drawing ko. Okay. For P waves, if it travels in only one density, in uniform density, meaning pare-parehas yung compactness ng materials. Let's say, nag-travel siya sa isang klase ng bato. Okay? So pagpasok niya sa bato, straight pa rin yung kanyang direction. Straight yung direction niya. Kahit saan man yan. Pag galing dito, straight. Okay. Pero, pagpunta niya sa increasing density, meaning, yung materials ay mas na-compress. Let's say dito, water. Dito ay, lava. Ayan. Dito ay, let's say, soil. Dito ay, solid rock. Ayan. So, patibay ng patibay yung ating pa-compact yung ating materials. Ayan. So, pag yung P waves galing dito, perpendicular to the boundaries, perpendicular siya sa boundaries, straight lang siya. Ayan. Pero, eto ngayon, erase muna natin yon. Where's my pen? Pero, pagka nag-travel siya dito with an angle, what will happen? Denser dito, faster dito. Ano mangyari? It will change direction. Pagdating na naman dito, faster. So, parang hindi na, para wala ng difference. Let's change that. Okay. Okay, so from this point, bibilis siya. Ayan. And then, magbe-bend na naman dito. Then, Ayan. So meron tayong bending ng P waves, bending ng ating waves. So it's already 10 o'clock. So imagine that this is the earth, although hindi siya yung tamang itsura. Uniform siya, pare-parehas yung materials niya. Let's say solid rock siya. So kapag yung P waves natin manggagaling dito, diretso lang siya. Pagkagaling dito, diretso lang siya. Ayan. Ayan, meron palang one arrow. So pag galing dito yung ating P waves, it will travel in straight directions. Okay? So kapag meron tayong mga seismic stations, etong mga seismic stations na to, this is where the instrument is located, they can detect the P waves. So they can detect the P waves from that point in a straight line, in a straight direction. But in reality, yung nangyayari ngayon ay eto. Pag si P wave galing dito, expected na madidetect dito. Pero in reality, hindi. Okay? Si P waves galing dito, expected sana in a straight line, although hindi straight yung drawing, in a straight line, madidetect dito. Okay? Pero, hindi na-detect. Dito, galing dyan, na-detect. So dito, expected sana is a straight line na-detect dito. Expected sana dito, na-detect, pero hindi na-detect. So meron tayong problema. Okay? Instead, saan na-detect yung wave na to? Yung wave na yan, na-detect sa banda rito. Okay? So, nag-bend. Ayan. So, yung wave na to, na sana, ganyan ang direction, nag-bend at, sorry for the mess, dito siya na-detect. So, ibig sabihin yan, yung ating mga waves ay nagbe-bend. So, pag nagbe-bend siya, ibig sabihin, meron siyang nami-meet na different densities. Meaning, ano ibig sabihin nun? So, most probably dito, may na-meet siya na mas compact. Pag proceed na naman niya dito, may na-meet na naman siyang mas compact. So, nag-bend siya ng nag-bend, kaya hindi siya nag-travel in a straight line. Okay. And using that concept, meron tayo ngayon, ayan, na-identify na nila, okay. Sabi ng mga scientists, okay. We therefore conclude, pag nag-bend yung mga P waves, ibig sabihin, yung Earth's interior, hindi lang iisang klase, iisang density. It should be composed of different densities. And these densities are in different layers. So yung layers natin ngayon ay composed of different densities of materials. And these layers caused the different waves to bend. Ayan. So meron tayo dito, P waves and S waves are felt here in this area. There are no P waves here. This is what we call the P wave shadow zone. Ito. Meron tayong na-detect na P waves dito sa banda rito. Can you see my cursor? Hello? Okay. Dito sa shadow zone na to, walang na-detect. Dito, ayan, P waves and S waves. Etong tanong, dito, bakit P waves lang ang na-detect? Eto, yellow. Yellow arrows, meaning P waves siya. Bakit P waves lang ang na-detect? Can anyone answer the question? Any volunteer? Bakit kaya P waves lang ang na-detect? Walang S waves.
There's only Because only P waves can pass through liquid.
Liquid and solid and gas. So kahit saan siya mag-travel, very good. So, meaning, pag P waves lang ang na-detect at si S wave hindi siya nakalusot, at alam natin na si S wave ay hindi makakalusot sa liquid, therefore, magkakaroon tayo ng idea na, okay, meron tayong liquid na parte, liquid part sa inner earth. Okay? So therefore, we have the subdivision of liquid outer core and solid inner core. So, ayan, yan na ang sagot. Paano na-identify ng mga scientists na merong mga layers? Gamit yung behavior ng mga P and S waves as they travel through the Earth's interior. Okay. Any question? May tanong?
None, sir.
Nagets ba? Nagets ba yung discussion?
Yes.
Oh,
Yes,
sige.
sir.
Tignan natin kung nagets yung discussion. It's 10:08. We'll consume 2 minutes. We'll extend at 10:10 only. 10 hours, 10 minutes. Okay. Let's summarize. What are the layers of the Earth's lithosphere?
Inner core, outer core, crust, and mantle.
Ayan, inner core, outer core, crust, and mantle. And, okay, this time, I'm going to call on a name. So, hindi kayo automatic mag-respond. I will call on a name. What are the 2 subdivisions of the Earth's core? May I call on Miss Aduka? Ano yung layers ng ating core?
Inner core tas outer core.
Very good. We have inner core and outer core. Diba? Ang dali. Okay. Now, this is the main question. How did scientists learn about the structure of inner Earth? Okay. This time, I would like to have a volunteer. But before you talk, please tell me your name. Ayan. I'm going to end the